I was a biochemist in Vienna, so really working with molecules. EMBL allowed me to transition to cell biology, looking at a much more complex system. And then in California, I was able to even work with organisms, so take it to the organismal level. And yeah, I had, through my EMBL context, then excellent postdocs. They got EMBL fellowship. So I stayed connected with the EMBL community. I met so many people then in the US who were also trained at EMBL. Yeah, so it's just widened my network quite a bit.
So when did you return to Vienna, and what was your ambition in returning here?
Yeah, I thought, so this was 3 years ago, and I actually had no immediate plans after 20 years in California to move back to Europe. We were really happy there, things were going well. But I always had an eye on this Institute of Science and Technology Austria here, which is a really unusual place, certainly for Austria, but I think also in Europe. And the opportunity to come here and support this institute through a really important second phase, expansion phase, as president, was just something I could not accept. And it also did play a role that I was born in Vienna. So it was sort of, and I feel it was easy for me to leave Austria when I was younger, but I think the older I get, I feel a very strong connection to Austria and Europe now.
And you can bring your experience from having worked in EMBL in California, and you can bring these learnings back and perhaps use that to fashion something exciting here.
Yeah, so what we tried to do here is in that sense similar. We're not structured in departments, not set up in a hierarchical way. So it's very collaborative. It's broader than EMBL or the SOG in the sense that we have everything from mathematics, computer science, quantum physics, all the way to astronomy. So it's much wider. Life science is about 50% of the institute. But yeah, it's this philosophy. One of the fascinating problems that we try to tackle, and that's is a big part of what we previously called sort of aging research, trying to understand how organisms age, what goes wrong, like why is it that many diseases are age associated, meaning that you have a high frequency of developing neurodegenerative disorders when you get older. So we try to turn this a bit around and ask, like, how can it actually be that our brain, for instance, which is composed of cells that are never replaced through a lifespan, can function for like a century in a human? And there we identified some new mechanisms that can be called maybe some maintenance mechanisms that really support, in this case, nerve cells for decades. And I think that's a general frontier now. When we talk about the brain, we still made major progresses as a community to understand how the brain is structured, how it's functioning. And I think a major frontier is like, how does this actually done now change during adulthood? And linked to that, the brain is not isolated in an organism. So now I think the next frontier is like, how are different organ systems interacting with each other? In the context of aging or at adulthood, we're just at the beginning of understanding how this complex system of an organism is actually maintained, what goes wrong when we get older. But then there's so many fundamental questions across all scales in biology that are, especially now that we have technology that allows us to look at bigger complex system, whether it's cellular or an entire organism, or even populations that are really transforming the way we understand life. So, and this is particularly interesting in an environment like this, where you bring people with very different expertise working on problems, and you have all these unexpected discoveries that pushed the field forward.
And this is, of course, a super important area for our society, because we are aging societies. We have probably average lifespans in Western societies much older than was the case before, and trying to understand how that might affect propensity to develop disease. Variation in genetics across populations obviously affects interactions with the environment and your probability of developing certain diseases. And I think there is a lack of real understanding of how this operates.
Yeah, that's absolutely true. And that, I think the way, I just talked about the organism as if the organism were isolated, but obviously how the organism interacts with the environment. Yeah. And let's take nutrition. We have, if you, look at publications about sort of non-scientific publications about what you should or shouldn't eat or shouldn't do to prolong your life. It's a vast volume of different advice. But if you look at what's really evidence and science-based, it's very little. So we understand very little how just nutrition and food impacts our health. And you mentioned the average lifespan, which is in Central Europe, it's around 82, 81. But the health span is only about 67, 68, right? So, which means around 10, 11 years of our lives we spend with some form of disorder or condition. And I think a major frontier of the next 50 years is to expand that health span to really make sure that we are staying healthier for longer.
How, as a director of an institute, do you see the rise of AI? Is this going to be a fantastic tool that will help to advance your research into new areas you couldn't do before? Or is it a threat? Is it worrying the young people coming through that maybe they will be redundant? How do you think we should manage this transition to an AI society?
Yes, on the one hand, it's clearly an extremely useful tool. I think there's no area here in research that is not either at least impacted, changed, or in some ways even transformed. But it's also, we are really at a critical moment, because you said the development has been extremely fast. And it has been much, much faster. Also, the scaling happened at a much higher speed than our understanding of AI. Yeah. And for the societal impact, which will be profound, I think we have to manage to invest in understanding of AI, to make it, we could call it trustworthy, reliable. It's none of those things, because in many cases we still don't understand it enough. There's still a lot of mathematics to be done, computer science, even physics and neuroscience. So it's in itself an interesting research topic, and we invest in that. But I think if we don't make this transition that people actually can trust AI, and now I'm talking about the broader implication in society and in effects from the legal system to the healthcare system, and it has potential to transform every field, I think we're going to be in big trouble. And I think it's a bit worrisome by that lack of understanding doesn't really keep up with the progress of development. And so I think there in Europe we have really an opportunity to play a role. I think we cannot catch up with the US and China in terms of building bigger data centers and scaling up. But we can make sure that the technology and the applications that we use AI for is aligned with our values. And so we can hopefully play a role in the direction, the trajectory that AI is taking.